This video demonstrates how easy it is to quickly create a production line with material flow objects, where a source produces parts that are transported over conveyors to specific stations and finally removed by a drain. To get started, start plant simulation and create a new model. Before creating our model, let's adjust the view. Go to the Ribbon tab view and click on Planning View. Now we see our model from the top. This makes it easier for us to place the objects on the right place. First, let's insert the objects we need: a source, 2 conveyors, a station, and a drain. To do this, select the source, move the mouse to the desired location within the frame, and click the left mouse button. This action inserts an instance of the source. The source generates parts and acts as a system boundary. Double-click on the source to open its dialog. Change the quantity from -1, which means the source produces parts endlessly, to 100 parts, so our simulation concludes after producing 100 parts. Click OK to save the change. Next, select the station from the toolbox and move the mouse to the desired location within the frame to place it. The station serves as an abstract representation of processes applied to parts. In the object dialog, you can manage and parameterize the procedure times of your station, such as the processing time, which you can change to a stochastic distribution. The parameter mu of data type time denotes the mean value of the normal distribution, while the parameter sigma of data type time represents the standard deviation of the normal distribution. Additionally, the optional parameter lower bound of data type time indicates the smallest value that the distribution can take, and the optional parameter upper bound of data type time denotes the greatest value that the distribution can take. Now, let's insert the 2 conveyors. Select the conveyor from the toolbox and place it between the source and the station within the frame. The first mouse click establishes the starting point, while the second click sets the end point of the conveyor. Hold down the Control key while clicking on the conveyor, then drag the new conveyor behind the station. This enables you to insert multiple copies of the conveyor. A conveyor is utilized to transport parts to the next work section. In the object dialog, you can configure parameters such as the speed and acceleration of a conveyor. Next, we connect the objects so that the parts can move from object to object throughout the plant. To connect multiple objects one after the other, select the connector from the toolbox, then hold down the Control key while clicking on the objects in the frame. To terminate connect mode, click the right mouse button or press the Escape key. The connector establishes the material routing. Lastly, we need a drain to serve as a system output and gather overall production statistics. To accomplish this, select the drain from the toolbox and drag it behind the second conveyor. If you place objects directly next to each other, they will automatically connect without the need for the connector to manually connect them. After switching off planning view mode, we are ready to run the simulation. To begin the simulation, click on the play button on the mini toolbar. This runs the simulation in real time. You can adjust the real-time factor by moving the bar on the strip or in the dialog of the event controller. In plant simulation, the simulation occurs through individual events. You can observe this by opening the event controller and clicking on the sign for the event debugger. Alternatively, you can open the event debugger by clicking on the event controller while pressing the Shift key. All steps of the simulation are listed here. You can utilize the fast-forward mode to run the simulation directly to the end. To review the results of the simulation, open the dialog of the drain and click on Type Statistics to view the most relevant statistical data of the produced parts. Here, you can observe, for example, the total throughput, which is 100 parts as we set the amount of the source to 100. Material flow objects can have multiple successors. To demonstrate this, let's adjust the model so that the station has 2 ensuing conveyors. Copy the conveyor and adjust the connectors accordingly. Now, we can manage the exit strategies of our station. To do so, open the dialog of the station and click on the Exit tab. Here, you can change the exit strategy, for example, to random. This strategy will distribute the parts to a randomly selected successor. As you can see, there is a checkbox that we can select. This checkbox determines whether a certain part being transported to its destination should be blocked if the destination cannot accept it. When you select blocking, the part will only move on if the desired successor can receive it. When you clear the checkbox, the part will move on if any of its successors can receive it. Now reset and start the simulation again. As observed, the station randomly distributes the produced parts to its conveyors. To learn more about conveyors and sources, you can watch the following videos about the respective topics. At the next we will show you how to work hierarchically with classes and frames in plant simulation. The objects in the material flow folder are classes of objects placed in the frame. Therefore, when you modify attributes of a class, the corresponding attributes of the object instances within the frame are automatically updated, as they are hierarchically linked to the class. In plant simulation, you can create multiple instances of the same object by right-clicking on the object you want to duplicate and selecting Duplicate. Duplicates will be placed in the User Objects folder, which automatically opens when you create a duplicate. Change the name of the duplicate to My Station and drag it to the User Objects ribbon in the toolbox. Now, insert one My Station between the upper conveyor and the drain, and a normal station between the second conveyor and the drain. Typically, you select objects from the toolbox and move them into the frame. Alternatively, you can select objects and drag them into the existing material flow by placing the object on the respective connector. As a result, the object is directly connected to the surrounding objects. Change the attribute processing time to 35 seconds in the class My Station. As you can see, it only changed the processing time of My Station and not of the first station. We have created two different classes that can be edited independently of each other. In plant simulation, models are constructed within frames. We will delve deeper into the various types of frames in the video on the introduction to 3D graphics. For now, we will just provide a brief explanation. The standard frame is the model frame, which plant simulation displays in the class library. The model frame inherently includes an event controller by default. The glass box frame displays its contents towards the outside, but not its default graphic. When you insert a glass box frame into your models, you typically want to view its contents. The black box frame creates a frame that does not show its contents towards the outside. Its content is represented by its graphic. To demonstrate how to work hierarchically with frames, create a new glass box frame by right-clicking on User Objects and selecting New. Then we delete the default graphic of the frame. Now rename the frame to Complex Machine. In plant simulation, you can work in different frames to have an overview of your models. It's easier to change or adjust something in one frame than to modify the entire model. A class is created for a special type of machine that is needed multiple times in manufacturing. Our complex machine frame should consist of a machine and a buffer. To achieve this, insert a buffer and the My Station. Furthermore, any changes made in the class will affect all instances used. Before we insert our complex machine frame into our model, let's make some adjustments. Delete the two stations and create a bit more space between the conveyors and the drain. Now, insert two instances of the complex machine frame onto each conveyor, and connect the buffers with the conveyors and the stations with the drains. Open the complex machine frame and double-click on the buffer to open its dialog. Change the capacity of the buffer to 12 and click on OK to save it. Let's open our model again and right-click on the buffer. Navigate to Complex Machines, then Buffer, and open it. As we can observe, the capacity has been adjusted in both instances of the complex machines frame. If a change needs to be made to the complex machine, we can do so once in the class. Automatically, all already used instances will adopt this change. Plant simulation offers you here an efficient way of working with hierarchical instances to get a better overview in larger models and thus to work more productively. For more help on material flow objects, open the online help. Click on Step-by-Step Help, then click on Modeling the Material Flow. That was a short introduction to building a simple model and how to deal hierarchically with classes and frames in plant simulation.